Today we are going to be looking at properties of parallelograms. So let's first take a look at our theorems. Theorem 6.1 states that opposite sides of a parallelogram are congruent. So if we take a look at our parallelogram, our opposite sides are congruent. Theorem 6.2 states that opposite angles of a parallelogram are congruent. So opposite angles of a parallelogram are congruent. So if we look at another picture of a parallelogram, opposite angles are congruent, so these two are congruent to each other, and these two angles are congruent. Theorem 6.3, the diagonals of a parallelogram bisect each other. Remember from the first trimester when we talked about bisect? Bisect is where it splits something directly in half, it cuts it in half. So if we are looking at a parallelogram, we have our diagonals, so going from opposite angle to opposite angle. Since it bisects, it's telling us that this diagonal is cut in half, so these two pieces are congruent to each other, as well as these two pieces are congruent to each other. So those are our three properties for parallelograms that we're looking at. So based on that information, let's find the values of x, y, and z in this parallelogram. Since we know this is 122 degrees, based on theorem 6.2, these are opposite angles, so the measure of angle z has to equal 122 degrees. So now we just need to find the measure of angle y and the measure of angle x. Since we know this is 32, right here with this diagonal we find out that we have a triangle. And remember, three angles in a triangle add up to be 180. So if we take 122 and add 32 together, we end up with 154. So if we look at that, 154, since we know three angles add up to be 180, the third angle, if we subtract it from 154, it's going to be 26. So this is going to be 26 degrees. So angle y is 26 degrees. Since this is 26, and we know that this is a parallelogram, so this is our transversal line. So remember, if we extended this, adjacent alternate interior angles are congruent. So this side has to be 32 degrees. Okay, let's take a look at example 2. We are going to be naming and finding which segments are congruent to each other. So we have segment XW, so this side right here, and that's going to be congruent to this side over here, so it's congruent to YZ. Segment W, or YN, this segment is going to be congruent to NW, because in a parallelogram our diagonals bisect each other, so that makes these two congruent to one another. And what angle is congruent to X, Y, Z? So this angle is congruent to opposite angles are congruent. So it's congruent to the measure of angle X, W, Z. Look at the back side. We are using the properties of parallelogram still. We want to find all the other angle measures. So we know the measure of angle 1 is 114 degrees. So being opposite angles, the measure of angle 3 also has to equal 114 degrees. So this is opposite angles. Since these are 114, these two angles need to add up to be 180. So 180 minus 114, that means angle 4 is going to be 66 degrees. So if we add these two, we get 180. Add those two, you get 180. So that means angle 2, since it's opposite angles, is 66 as well. So the measure of angle 2 and the measure of angle 4 is 66 degrees. Alright, first things first, we need to change one of these. I want you to change the y minus 1 and turn it into 3x minus 6. So we want to find the values of x and y. Well, we know that the diagonals in a parallelogram bisect each other. So that means that 2x minus 1, that length, is the same as 3x minus 6. So we subtract 2x to both sides. 2x minus 2x becomes 0, so we're left with a negative 1, equals 3x minus 2x leaves us with 1x. We can add 6 to both sides. Negative 1 plus 6 is 5, so x is 5. So now we can find y. Since the angles or the diagonals being bisected, 3y minus 11 equals x plus 4. So we can combine our x's, so subtract an x. Oh, sorry, nope. We know x is 5, so this turns into 3y minus 11 equals 5 plus 4. 5 plus 4 equals 9. And if we add 11 to both sides, 3y and negative 11 plus 11 is 0. 9 plus 11 is 20. So our last step would be to divide both sides by 3. So y equals 20 over 3. Alright, last theorem. Theorem 6.4. It states if 3 or more parallel lines cut off congruent segments on a transversal, then they cut off congruent segments on every transversal. So let's look at example 5 and put this together. We have parallel lines. We are stating that AB, BC, CD are all equal to each other. So we want to find, so these are all congruent, the length of JK. So since we know these are all parallel lines being cut by a transversal, these are all congruent, JK has to be congruent to KL and LM. So that means JK has to equal 4. And GH is congruent to GF, which is congruent to FE, so it equals 5.3.